So, well, in today's lecture, we're going to look at how to solve the following non-linear ordinary differential equation: y prime times y double prime equals 4x, given the initial conditions that when x is equal to 1, y is equal to 5, and when x is equal to 1, y prime is equal to 2. Now, y prime and y double prime are simply derivatives of y with respect to x. So y prime is a derivative of y with respect to x, and y double prime is simply the second derivative of y with respect to x, or d squared y by dx squared. Now, how do we solve this non-linear ordinary differential equation? Well, non-linear or differential equations often tend to be very, very difficult and complex to solve, if indeed one can solve them. There are a number, of course, that one can solve, but you need to know the techniques required to go forward and obtain solutions, legitimate solutions, and sometimes there's more than one. In this case, we're going to now have a go at solving this equation: y prime y double prime equals 4x, and what I'm going to do is start by writing the equation down again, and we'll go from there. So if I just let me see, there we are. Click on that, and so we've got y prime y double prime equals 4x. This is exactly the same as writing dy by dx times d squared y by dx squared. I can't, that too may not look very clear there, but anyway, we'll take a chance with it, and that is equal to 4x. Now that looks really quite complicated because often most people are used to solving equations like d squared y by dx squared equals x, for example, without, say, another derivative dy by dx on this side or the right hand side, or anything like that. But we can actually simplify this equation, which I'll call equation 1. And we do that by using a substitution. So we say let u equals dy by dx. Okay. So we can substitute u in for dy by dx over here in equation 1. But what do we do with the d squared y by dx squared bit? Well, we can, we'll call this, in fact, we'll just leave it as it is. We've got u equals dy by dx. And this implies that if we differentiate again with respect to x, just let me, there we are. So if we differentiate dy by dx again, we get d squared y by dx squared, and that's equal to du by dx. Okay, so we can now substitute this part, u equals dy by dx, and the second part, d squared y by dx squared is equal to du by dx, into equation 1. So what we have is let me see. We've got u. So I'll write it out like this. So dy by dx equals d squared y. Sorry, I've made a mistake. Do excuse me. So we've got dy by dx times d squared y by dx squared. And that left-hand side is now equal to u du by dx, right? So we can substitute this u du by dx into the left-hand side of equation 1. So we get, let me line that up a little bit better. So we get u du by dx, I ought to put so there, is equal to 4x. So u du by dx is equal to 4x. Now, we can separate the variables effectively. In actual fact, what we're going to do now is integrate with respect to dx, so that we get the integral of u du equal to 4 times the integral of x dx, right? And if we integrate that, we get u squared over 2 equal to 4x squared over 2 plus a constant, which we will call C1. Constant C1 is basically a constant of integration. Now, I'm just going to simplify this equation. We'll call this equation 2 by multiplying through by 2. So we get u squared. I'm going to leave that as u squared for now on the left hand side. The two cancels here, so that we get 4x squared plus c2. C2 is just equal to C1 there. So now we can rewrite this, if you remember, u, we'll put but there, but u equals dy by dx, okay? So we've got dy by dx all squared equals 4x squared plus c2. And we have to find the constant c2, right? And how do we do that? Well, we know, and I'll write this in red, we know that, so if we write down the initial conditions again, when x equals 1, y equals 5, and y prime, which is dy by dx, is equal to 2, right? So what we do is we substitute the y prime part, so the 2, y prime equals 2, we substitute into the left hand side of this equation, which we'll call equation 3. So we substitute y prime equals 2 into the left hand side of equation 3, and we substitute x equals 1 into the right hand side of equation 3. So that we get, let's just move down here, make sure we've got black ink. So we've got 2 squared equals 4 times 1 plus C2. So we've got 2 squared, which is 4, equals 4 plus C2, and this implies that C2 equals 0, because you just subtract 4 from both sides, and the 4 disappears from the right hand side and the 4 disappears from the left hand side. Hence, we can write down, hence, dy by dx all squared equals 4x on its own. So 4x, and we'll call that equation 4, right? Now, have I done that right? Let me just, it's a 4x squared, isn't it? Yeah, so I thought there was something I was missing out. So dy by dx all squared equals 4x squared. So taking the square root of both sides, so the square root of the left-hand side equal to the square root of the right-hand side, yields dy by dx equals 2x squared. Now, you might ask, aren't there two versions of this? So, isn't it true that we have a dy by dx equals 2x and a dy by dx equal to minus 2x, like that? Let me just make that look a little easier to read. Right, okay, so that's, you might say, is that equal to minus 2x squared? Well, in fact, I've made a mistake, haven't I? Let me just go back. I had it right the first time, but we don't want the squared term there because we've taken the square root of both sides of equation 4. So isn't it true that we have dy by dx equal to minus 2x? Well, when you take the square root of both sides of equation 4, what you actually have is plus or minus the square root of, I'll just write this as y prime all squared, equal to the square root of plus or minus the square root of 4x squared. So in actual fact, you have a positive square root of y prime squared equal to a positive square root of 4x squared. And if you work that out, you get what we've got here, dy by dx equals 2x. But if you then take the negative square roots of both sides of that equation, you have minus the square root of y prime squared equal to minus the square root of 4x squared. And of course, these negative signs cancel out, leaving you with the positive square roots again, like so. And so we end up with y prime equals 2x. So it's the same in both cases. So we only have ultimately one solution for this. So I'm just going to erase all of that in red because we want to leave a little bit of room for our main working. But you can scroll back on the YouTube video and look through that again if you so wish. Let me just get rid of that squared term again. Seems to have reappeared. There we are. So now we've got a very simple ordinary differential equation here, and I'll call that equation 5. So integrating both sides with respect to x, we find that y equals 2x squared over 2 plus, is it c, what constant do we call it? So we've got c2 there, c2, so we want a c3, don't we? Okay, c3, and again we use our initial conditions. So and I'll write this in red. Let me see, red, yeah. Initial conditions state that when x is equal to 1, y is equal to 5, I think. Yeah, right. Make that look more like a 5. So we've got 5 equals x squared. Well, actually, those two's cancel, don't they? So we've got 5 equals 1 squared plus c3. This means that c3 equals, well, you subtract 1 from both sides, you get 5 minus 1 on one of the sides, and that's equal to 4. So our particular solution can now be written as, and we'll just write it down. So we have y equals x squared plus 4. And let's check that we've got the right solution. I mean, I know that that is the right solution, but we want to double check that it is. So if we find y prime, then we've got 2x, and y double prime is equal to 2. I should put right check at that side. So if we go back to the original equation, equation 1, we've got y prime, y double prime, and that's equal to, well, y prime is equal to 2x, and y double prime is equal to 2, which is 4x. And of course, we know that's right because, oops, gone back to some earlier working there. Let's just go down. Yeah, in equation 1, well, actually, it isn't equation. Well, it is equation 1, isn't it? There, we have y prime, y double prime equals 4x, and of course, we've just determined that that is the right solution because when we find both the derivatives of the solution, y equals x squared plus 4, and substitute them back into the left-hand side of equation 1, we find that the answer is 4x. So y equals x squared plus 4 is the correct solution. So thank you very much for listening. I hope you come back for my next video, which will be on another nonlinear ordinary differential equation. And until then, I bid you farewell and see you soon. Bye.